talk about nth roots, understanding what they mean, how to simplify them. Okay? Copy this down, please. Put your phones away. So we'll say this again. Since 5 squared is 25, 5 is the square root of 25. And since 5 cubed is 125, then 5 is the cubed root of 125. And since 5 to the 4th is 625, then 5 is the 4th root of 625. And what's the last one going to say?
5 is the 5th root
Of?
3125.
That's correct. So fill those in, please. And you're welcome. You know, right now you're thinking, I'm glad I didn't have to copy all this down. You're welcome. Okay. So this pattern continues, leading to the definition of the nth root, which says, in symbols, for any real number a and b, and any positive integer n, if a to the n is equal to b, then a is the nth root of b. That's our definition of the nth root. Since 2 to the 4th is equal to 16, and negative 2 to the 4th is equal to 16, so both 2 and negative 2 are 4th roots of 16. That's correct. 4th roots of 16. Since there are no real number x such that x to the 4th equals negative 16, negative 16 has
Unreal.
no real 4th roots. Good. Since negative 5 is the only real number whose cube is negative 125, negative 5 is the cubed root of, the only real cubed root of negative 125. So the following chart sums up the concept we're trying to get across here. So the type of number. Up here we had a positive number, and it had how many real roots? 2. And it was an even root, wasn't it? Okay. Then we had an even root with a negative number right here. And how many real roots did it have? None. Okay? And then we had a negative number and an odd cube is an odd power. And how many real roots did it have? 1. So let's go down here. Type of number. Positive number. Number of real nth roots when n is even. So we have even root. Positive number. How many real roots are there? 2. There are 2. I tried to put boxes in here that would move out of the way, and this table that I used to draw this kept absorbing them into the table and replacing the numbers I had in there, and it wouldn't work. And so I don't know how to make it work other than I'm just going to pull this down. If we have an odd number, how many real roots are there? 1. Okay? 1. So if we have an even power with a positive number, we have 2 real roots. If we have an odd power, a positive number, we have 1 real root. Moving down. If our number is 0, how many real roots are there? 1. Fifth root of 0 is 0. The sixth root of 0 is 0. Okay? So there's just one either way. Now, if it's negative, and my power is even, how many real roots were there? 0. And if it was odd? 1. Come on. Now there we go. So we get none or 0 and 1. So make sure you have that information. Moving on. Find all the real roots. Cube roots of 27. Cube root of 27. These are all cube roots. And these are all fourth roots. Okay? So what's a cube root of 27?
3, negative 3, or 3?
Good question. 3 and negative 3 or 3?
Just 3.
Just 3. Why not negative 3?
Because the power is out.
Okay. And there's going to be how many real roots in? 1. Because it's an odd power. Remember, negative 3 times negative 3 is positive 9, times negative 3 is negative 27, right? So that wouldn't give me a positive 27. So there's just 1. It's 3. Okay? The cube root of negative 64. How many are there? 1. What is it? Negative 4. Negative 4 times negative 4 is 16. 16 times negative 4 is 4. Or, sorry, negative 64. Forgot which way I was going. And 729. What's the cube root of 1 over 729? 1 over 729. Well, what goes on top? What's the cube root of 1?
1.
1. And the cube root of 729?
Oh no.
9 times 9 is 81. 81 times 9 is 729.
Is there a way to find out in your calculator?
Yeah. I go cube root 1 over 729.
Oh.
Okay? But we're going to talk more about that in just a moment, because that's in this question that doesn't necessarily give all the answers. Okay? Let's move down here. What's the fourth root of 625?
5 and negative
5 and negative 5. Okay, I agree with that. Or I could write it this way. What's the fourth root of negative 1 10,000?
Can't do it.
Can't do it. Why?
Oh, yeah.
Okay, so what is the answer?
No real.
Okay. No real root. Okay, no real roots. And how about 16 over 81? 2 over 3, that's right. 2 times 2 times 2 times 2 is 16. 3 times 3 times 3 times 3 is 81.
And negative 2 and 3.
Good. Good call. All right? Any questions on that? All right, now, we're going to talk about explaining this just a little bit more. The radicand sign is used to indicate a root. The radicand sign is used to indicate a root. The number out front is called the index. Sorry, I read that wrong. The radical sign, not the radicand sign. There we have our radical symbol, and this is our radicand. That's where I got the word Radican from. But. So, the number out front is the index. When that number's a 2, do we write it down? No. But any other number, we need to write it down. Okay, if it's a 3, 4, 5, 6, whatever, we need to write it down. The radical sign is what we think of as a square root symbol. That's the radical sign. And then the radicand is the number that's inside of that. When a number has 2 roots, the positive root is called the principal root. When a number has 2 roots, the positive root is called the principal root. And the radical sign indicates the principal root. So this, I'll come right back to that, don't panic. This right here, I said we'd talk more about this. This means the principal root of that. Now, because it's an odd power, it's an odd root, the index is 3, then they're only going to get one answer. But if it was a 4th root, 5th root, or whatever, 4th or 6th or square or 8th root, we would only be talking about the positive one when it's written that way. Okay? So, the principal 5th root of 32 is written as the 5th root of 32. And again, because it's an odd root, there's really only one answer. So, calling this the principal 5th root is kind of misleading. I should have said the 6th root. I should fix that in my notes before I do this again, shouldn't I? Okay? The 6th root, change my number to 64 or something. Find each real root. What's the cube root of negative 1,000? Negative 10, I agree. What is the 4th root of negative 81? It's a negative, right? And it's an even root, so there are no real roots. And I think that's just a slip up there. I guess it's really a slip up. I don't even know what's going on there. Okay. Now, notice, as we read through this, notice that when x is equal to 5, the square root of x squared is equal to the square root of 5 squared, which is what? What's the square root of 5 squared? It says right here, I'm not trying to trick you. It's 5, right? And so our squares and our square roots cancel, and so we get x is equal to 5. That's what we started with, wasn't it? So if x is 5, the square root of x squared is the square root of 5 squared, which is 5, so x is still equal to 5. But when x is equal to negative 5, the square root of x squared is equal to the square root of negative 5 squared. What's negative 5 squared? That's square root of that's square root of 25. And square root of 25 is 5, which is not equal to x, is it? So you see what happens? My negative there gets lost, doesn't it? And so that doesn't work when it's negative. And this leads us to this property. The nth root of a to the n when a is less than 0. So a, our radicand, is a negative number. The nth root of that negative number, for any negative real number a, the nth root of a to the n is equal to the absolute value of a. So we have to end up with a positive number. We can't take the square root or the even root of a negative number, can we? So we have to end up with a positive number. So we have to throw absolute values in there when n is even. Okay? So, we're going to simplify each radical expression here. And so in doing this, I'm going to break it up this way. Oops, sorry. Didn't mean to write 10. Let's write x to the 10th. What's the square root of 9? 3. Now, there's a couple ways to look at this other. Okay? Anybody know what the square root of x to the 10th is?
X to the 5th.
It is. Exactly. That's correct. X to the 5th. There's a couple ways of looking at it. Alana, please follow along. You could rewrite this as x to the 5th squared inside my radical sign. Remember, you raise a power to power, what do you do with the exponents? You times them. What's 5 times 2? 10. That's how many x's I had here, right? 10 of them. X to the 10th. And so this x to the 5th squared, now what's happening with my square root and my square? They're canceling each other out, leaving me with x to the 5th. And so I get 3x to the 5th. Okay? Another way of looking at this is I can look at it this way and break my x to the 10th up into 5 sets of x squareds. And what's the square root of x squared? X. And the square root of x squared? X. And the square root of x squared is x. And the square root of x squared is x. And the square root of x squared is x. And when I'm done, I have x to the 5th power. So there's more than one way of looking at it. Some of you will look at it, you're really good with these things, and you'll see it, and it'll make sense, and you'll just know what it is. Others, you're going to have to break things up a little bit. Either say, how many x squareds do I have? And do it this way. Or say, well, how can I break that 10 factors of x up so it looks like something squared instead? Okay? Now, just real quick, if I do square root of x cubed, that's equal to the square root of x squared times square root of x, isn't it? X times x squared is x cubed. So my square root of x squared just becomes x, but my square root of x, I can't do anything with that. There's an odd number in there. They don't work out perfect. So sometimes when you simplify, you could be left with variables inside the radical sign. And that could happen. All right? They aren't always going to work out like these. I'm looking at these, and I picked all perfect examples. Okay? So what's the cube root of a cubed b cubed? AB.
Good job, Dale.
It's AB. That's correct. Now, I need to be careful. I got to back up here. I forgot one thing here. Anybody know what I forgot when I left my answer right here? I forgot one thing. What if x represents a negative number? Can I get a negative number? I can. I can. And if I did get, say I got negative 2, what would negative 2 to the 5th end up being? A positive or negative?
Negative.
A negative. And what did this just say? I can't end up with a negative. So when I get done, if I have an odd, if I'm doing an even root, I just put an E there. For an even root, and I get done, I have an odd number of factors, I have to throw absolute values in there. If I ended up with x to the 6th, then it wouldn't matter, because x to the 6th is going to be an even number anyway, isn't it? I'm sorry, a positive number. If you multiply something by itself an even number of times, you're going to get a positive number, right? 2 times 2 times 2 times 2 is 16. Negative 2 times negative 2 times negative 2 times negative 2 is 16. So it wouldn't matter. But in this case, because I have an odd power and I had an even root, I have to throw in my absolute value. Now in this case, I have an odd power, but I had an odd root. So if my a's are negative, then these are going to be negative numbers. If my a's are positive, then these are going to be positive numbers. So it doesn't matter. I get what I'm supposed to get. And now I'm back down to an even root here. Okay? Fourth root. How could I rewrite x to the 4th, I'm sorry, x to the 16th by making it look like a fourth power. What would go inside? X to the 4, that's right. 4 times 4 is 16. Y to the 4th. So what's the 4th root of x to the 4th? X to the 4th. And what's the 4th root of y to the 4th? Y. And so does this need to be in absolute values? That one right there, does that need to be in absolute values? No, because that's to the even power. So if it's a negative number, it's going to become positive anyway. How about the y? What's the power on the y? 1. That's an odd number, right? What was my root? That's an even number. So that means I need absolute values on that. So it's the 4th root, I'm sorry, it's x to the 4th, absolute value of y. That's the way you need to leave that in. Right? This will make more sense when you've done more practice on it. Okay? Just seeing me do 1 or 2 of these is not going to totally clear that up. All right. All right, please. We'll start out with the odds. If we're going to waste time, then I'll change odds to all.